In this video, we're going to take a look at the homologous series of alcohols, ethers, aldehydes, and ketones. Let's start out with alcohols. So alcohols is a class or a homologous series of organic molecules. It has a functional group formula of ROH. Remember, R can be any alkyl group, so it could be 1 carbon, 2 carbons, so on and so forth. The functional group name is called a hydroxyl, so that is the OH group of alcohols. A good example of an alcohol is ethanol. So ethanol has a 2-carbon formula, so CH3, CH2, and then OH. So here is our R group, and then here is our functional group, our hydroxyl group. So this is ethanol. Moving on, our second homologous series or class that we're going to look at are ethers. Ethers are characterized by having alkyl groups on both sides of an oxygen. So it's almost like an alcohol, except the hydrogen here is replaced with another alkyl group. Now, the two R groups do not need to be the same and typically aren't. The functional group name is called an alkoxy, so it depends on the size of the smaller chain what that alkoxy name is. So it can be like methoxy, ethoxy, propoxy, etc., and so on and so forth. An example here is methoxyethane. So the methoxy is coming from this part of the name, and then the ethane is our longest chain, and that is going to be our parent chain, so that's what we're naming it after. So this is methoxyethane. And we'll get into the naming of all of these compounds in a separate video. Moving on to aldehydes. So aldehydes are characterized by having an alkyl group, and then its functional group is a carbonyl. So a carbonyl is a carbon double bonded to an oxygen. And aldehydes characteristically have a hydrogen on the other side of this carbonyl group. So an example would be ethanal. So ethanal is a 2-carbon aldehyde like so. Now, this functional group part of an aldehyde can be also represented if it's written just in a full sort of single line as CHO. When you see a CHO, that means it's an aldehyde group. So two sort of representations of how that works in particular. And our last homologous series or class are called ketones. Ketones are like aldehydes. They have a carbonyl functional group, except instead of this hydrogen, kind of same with the alcohols and the ethers, they have another alkyl group on the other side of the carbonyl group. The two R's do not need to be the same, okay, so they can be different. An example here would be propanone. Sorry, I'm trying to think about it as I'm drawing it. So this is propanone. It is a 3-carbon ketone. Now, similar to aldehydes, this can be written all in the same line as well, and it looks a little funky. So if you see it written all in one line, it's going to be written as CH3, and then the C and O will be in brackets, and then the CH3. So looks a little strange, but those two formulas are interchangeable with one another. So that is alcohols, ethers, aldehydes, and ketones. That's it for this video. We'll see you in the next one.